Principles of Bioproduct Separation, Module 10, Precipitation, Segment 1, Precipitation with a Non-Solvent. With me, Yusuf from School of Life Sciences and Phenology, Institut Teknologi Bandung. Precipitation is an easy, straightforward method of purifying biological solutes. In this module, we will discuss about precipitation with a non-solvent, precipitation with salts, precipitation with temperature, and last but not least, large-scale precipitation. At the end of this module, students will be assigned to do several exercises to determine amount of non-solvent, determine concentration of enzyme, determine diffusion time, and last but not least, determine precipitation time and concentration of particles. A suitable solvent can be added to a feed solution. The solvent is miscible with the feed but causes solids to precipitate. At equilibrium, the chemical potential of the solid precipitate is the same as that in solution, which can be expressed by equation 1. When the non-solvent is added, the standard state chemical potential is raised as shown in the figure. The result is that the solution becomes supersaturated and precipitation occurs until a new saturated concentration is reached. What are the non-solvents? This question has different answers depending on whether the precipitate has a moderate molecular weight, like an antibiotic, or high molecular weight, like a protein. For antibiotics, the feed is commonly a solution in a solvent, like ethanol, acetone, or t-butanol, and the non-solvent is water. For proteins, the feed is usually an aqueous solution at the isoelectric pH. Under isoelectric conditions, the protein has equal number of positive and negative charges, and its solubility is often a minimum. The non-solvent is frequently a water-miscible organic solvent, like acetone or ethanol. There are 5 heuristics in precipitation. First, precipitation at low temperature increases yield and reduces denaturation. Second, precipitation is best at ionic strength of 0.05 to 0.2 molar. Higher ionic strength requires a solvent and more dilute solutions yield a finely divided precipitate which is difficult to filter. Third, high molecular weight solids require less solvent to initiate precipitation, which can be estimated by the equation shown in the slide. Fourth, the solubility of one protein is usually decreased by the presence of other proteins. And fifth, precipitated solute which will not redissolve is probably denatured. Often such denaturation compromises yield, but sometimes it produces further purification. In the next segment, we will discuss about precipitation with salt. Until then, I am Yusuf from Institut Teknologi Bandung.